Oh.
Good evening to all. I would like to welcome you all for this webinar program on grid modernization and smart grid. First of all, I would like to welcome our Honorable General Secretary and Correspondent to G. Ganeshan. I welcome you, sir. It's immense pleasure to welcome our resource person, Professor Ravi Samikannu, Associate Professor, Department of Electrical Computer and Telecommunication Engineering, Botswana International University of Science and Technology, Botswana. I welcome you, sir. I extend my warm welcome to all participants, our students, future engineers, faculties, HODs, and VPs. I welcome you all for this webinar program. Sir, now I request our secretary, sir, to give you a welcome address. Oh, sorry, sir.
Sure. Yeah.
Welcome address again.
Okay. அனைவருக்கும் இனிய மாலை வணக்கங்கள். இங்கே நம்முடைய அழைப்பை ஏற்று வருகின்றிருக்கக்கூடிய நம்முடைய சிறப்பு விருந்தினர் திரு டாக்டர் ரவி சாமிக்கண்ணு, போட்ஸ்வானா அவர்களை நம்முடைய எம்ஏவிஎம் சபை மற்றும் சாக்ஸ்-Mavmm பொறியியல் கல்லூரி சார்பாக வணக்கத்தை தெரிவித்துக் கொள்கிறேன். வணக்கம் சார். மேலும் இந்த வெபினார் நிகழ்ச்சியில் கலந்து கொண்டிருக்கக்கூடிய நம் கல்லூரி முதல்வர், துணை முதல்வர்கள், நம் கல்லூரி பேராசிரியர்கள், மாணவர்கள் மற்றும் இங்கே வந்திருக்கக்கூடிய +2 மாணவர்கள் மற்றும் அவருடைய பெற்றோர்கள் அனைவருக்கும் இந்த நம்முடைய சாக்ஸ்-Mavmm பொறியியல் கல்லூரி சார்பாக மாலை வணக்கத்தை மற்றும் மகிழ்ச்சியை தெரிவித்துக் கொள்கிறேன். உங்களுக்கெல்லாம் தெரியும், பாரம்பரியமிக்க 80 ஆண்டு கால நம்முடைய எம்ஏவிஎம் சபையின் அங்கமாக திகழக்கூடிய சாக்ஸ்-Mavmm பொறியியல் கல்லூரியானது கடந்த 22 ஆண்டு காலமாக மதுரையில் சுமார் 6500க்கும் மேற்பட்ட பொறியாளர்களை உள்நாட்டிற்கும் வெளிநாட்டிற்கும் தந்து அளித்திருக்கக்கூடிய ஒரு பெருமைமிக்க கல்லூரியாகும். இந்த வெபினார் செஷனை முழுமையாக நம்முடைய கல்லூரி மாணவர்கள் மற்றும் +2 மாணவர்கள் மற்றும் பெற்றோர்கள் அனைவரும் கண்டுகளித்து இதை பயன்படுமாறு கேட்டுக்கொள்கிறேன். நன்றி, வணக்கம்.
Now I call upon Dr. Ravi to give a lecture on grid modernization. Before that, I request our Dr. G. Emily Madam to give a small introduction about Dr. Ravi sir.
Okay, sir. I welcome all the participants from various colleges and our guests and our General Secretary and Correspondent and Principal sir for this technical webinar. First, I feel sorry for this technical inconvenience problem, and I like to introduce our chief guest, Dr. Ravi Samikannu. Dr. Ravi Samikannu has rich experience in the field of electrical power system, especially in renewable energy system and intelligent control for power system. He has attained his doctoral degree in electrical electronics engineering from Anna University in 2012. He has rich teaching experience in various esteemed institutions in India and in foreign countries like Tanzania, Malaysia, and Ethiopia. At present, he is working as associate professor in Botswana International University of Technology, Botswana. He has published more than 60 papers in the referred international journals and more than 50 international conferences, and his publications include 6 international books and publications. He has taken up many government-sponsored projects under the Ministry of New and Renewable Energy Sources, and he's also guiding several PhDs, and he's also promoting rural community livelihood services. We like to have such an eminent personality with us. With these few words, let I welcome Dr. Ravi Samikannu sir to deliver his technical speech. Thank you, sir.
Good evening, madam.
Good evening, sir.
Good evening to everyone. Whether the slides are visible to everyone?
Yes, sir.
Yes, sir.
Okay. The today topic is about the grid modernization and the smart grid. I am Ravi, working as associate professor in Botswana International University of Science and Technology, Botswana. And the contents about the today's session is going to have the energy per capita, and then information about the electrical grid, structure of the existing grid systems and the challenges in the existing grid systems and how we are modernizing the grid. The modernization of the grid we mention in the name of smart grid and the different components of the smart grid, and we are going to see about different case studies and the references. When we look about the energy per capita, it is an important term like per capita income. How a country's wealth, it is determined by the per capita income. The same way, the electrical energy per capita is also an important factor to know about the country's wellness. So here I just specified what are the top 20 countries from 1960. If you go through the link, you can able to understand the top 20 countries which are consuming more electric power. When we look from this picture, if you look United States and China, they are consuming more electricity. Next to that, India and Russia, Australia, Canada, they are consuming the more electricity. Here, you can able to see the chart. You can see the below 50. The below 50, it is millions of tons of oil equivalent. We mention it as MOTE. MOTE, that is millions of oil tons.
Ravi sir,
Equivalent.
please switch on your video, sir.
Okay. Okay. So when we look, China and the USA, they are consuming more electricity in the world. So here I given the chart. This table, if you see, we can able to see what is the electricity consumption in kilowatt hour per year. If you look, China is in the top. Next to China, United States, and third, India. India and China, their consumption is more because of the population. So otherwise, if you look, United States, they are the major electricity consumption country in the world. Then this is the global primary energy consumption. This global primary energy consumption, it shows that in terawatt hour, how much amount of terawatt hour energy is consumed by with the help of different energy resources. Like if you see traditional biofuels, coal, crude oil, natural gas, and hydropower, they are the major sources which is used to generate the electricity. Here, other renewables means it is not including the solar and wind and hydropower. So other renewables, we can say biomass, like other resources. So if you look, the contribution of traditional fuels, coal, crude oil, and gas, they are used to generate more electricity in the present scenario. Here I am showing the another table. If you see the another picture, in the another picture, this is the picture. It is shows in 1965. In 1965, if you see the amount of renewable contribution, it is only 17.99 terawatt hour. It is increased in 2000 as 185.45 terawatt hour, excluding the solar, wind, and nuclear and hydropower. If you include this other renewables contributing 625.81 terawatt hour in 2018. So when you see in the 18th century, in the initial stages of the 19th century, the contribution of the renewable resources is very less, but slowly it is developing. Now, if you see, we are moving towards the usage of renewable sources to generate the electricity. So normally, we say electrical grid and structure. If you look electrical grid, or we can mention it as a power grid. The electrical grid or power grid, it is going to have different components like generation components, transmission and distribution components. Then it is going to have the consumers. The consumers can be an industrial consumer, commercial, and the residential consumer. So if you look into the generation plants, that is having different types of power plants. The power plants can be a coal-based power plant, or it can be a hydropower plant. The hydropower plant may be a large hydropower stations, or smaller hydro power stations, and then nuclear power stations, solar power stations, wind power stations. So these resources, it is not available in same places. So these resources, it is scattered. So the generation stations, it is in different places. So they generate the electricity. The generated electricity, it is in the ranges of 11 kV and 33 kV, maybe 11 kV or 33 kV, depend upon the capacity of the power plant. The generated electricity by using the substations, like by using the step-up transformers, the 11 kV or 33 kV, it is stepped up to higher voltages, 132 kV or 220 kV, depend upon the capacity of the transmission lines. Then, if you look the transmission systems, it is divided as primary transmission and secondary transmission. The stepped up voltage, it is transmitted, and again, it is stepped down to the rating of 11 kV. From 11 kV, again, it is stepped down through the substations, it is supplied to the consumers. When we look why we are stepping up the voltage, we are stepping up the voltage to reduce the current loss. So when we increase the voltage, the current is reduced. So I squared R loss, it is going to be less when we are doing the primary transmission. So the primary transmission length is very high. So we need to reduce the I squared R loss. This is the electrical grid and structure. When we look at the electrical grid, it consists of all these components, including the consumers. So when we look the installed capacity by source in India, according to the data up to the 31st March 2020, India is majorly dependent on the coal power plant. If you look this picture, we can see the coal power plant, it is contributing around 55.4% of electricity in India. Then next to coal, India is using more hydro power plants. Next to hydro, India is dependent on the wind power. Then next to that, solar. Then we are having the nuclear, gas, and the diesel power plants also. We cannot able to eliminate the diesel power plants because in the rural areas, still they are using the diesel generators. So India majorly depend on coal and hydro power plants. So if you look about the status of other continents, Western and Eastern Europe regions, they are majorly having the countries Germany, France, and UK. They are having 14,000 transmission substations, 44,000 primary distribution substations, and 1,000 more secondary distribution substations. Then when we look into the Latin America, Brazil and Mexico, they are the major power consumers. When we come to the Middle East, you know, they are majorly using the oil and gas. Africa, they are majorly depend on the coal power plant. When we look into the Asia, it is having a more population. The major countries like China, India, Pakistan, Bangladesh, they have more population. Majorly, all these Asian countries, we are depending on the coal power plant and the hydro power plant. So when we look into the power system, when we are supplying to the consumers, it should given in a less cost. The electricity should be given to the consumers in less cost. We should give in a proper security. That means the network should not be affected. Then quality of the power supply is much important. We need to give proper voltage and the proper current and frequency. Then environmental, it should not be affected. But when we look the present systems, there is a problem of security and we are not able to give the power in proper quality. Then we have the environmental issues because we are majorly dependent on the coal. So the coal, it emits the carbon dioxide, so it is affecting the environment. So the power system should manage this all four, and also it should maintain the normal state. Sometimes when there is a fault happens in one phase, the fault in one phase, it should be eliminated immediately. If it is not eliminated immediately, then it is going to the next stage that we can say it is the alert stage. So we need to move the system from alert state to the normal state. If we are not eliminating the fault at the stage of alert, then it creates the next faulters. Then this fault, it is going to create disrupted and restoration. So again, we need to restart the system from the normal. So this is increasing the loss in the electricity grid. So when we look initially in earlier days, we give more importance to the energy flow. We don't give importance to the information flow. But nowadays, we are giving more importance to both the energy flow and the information flow. So if you look the energy flow, the power it is generated in the power plant, it is transmitted and distributed through the substation. We are connecting to the consumers. Initially, we don't have a information flow between this power plant and the power system control. But nowadays we improved here. So we are having a information flow. We can able to get updated information. What is happened in the substation, or what is happened in the power plant, or what is happened at the consumer side. We are facing different problems in the conventional grid. The conventional grid is the one which we are using now. So what are the major problems we are facing in the conventional grid? First, we can say inadequate last mile connectivity. Still, we have some villages, they are not connected with the electricity. We can say some of the tribal areas, they are not connected with the electricity. So we have an inadequate last mile connectivity. This happens because of the investment cost. When we are extending the grid, existing grid, we are spending a much money, and we are going to supply to only 15 or 20 customers. So in that case, the government, they want to do distributed energy generation instead of extending the electricity grid. Then unequal electricity distribution, because we can still, we know in we can see it in the urban and rural areas. So where we have more industries, there we need to supply the electricity continuously. But when we are thinking about the villages normally we disconnect the electricity. So there is an unequal electricity distribution between the rural and urban areas. Then erratic power pricing. This erratic power pricing, it is happening because of the increase in the electricity. It is not done by the utility grid every year. Normally what the utility grid it is doing, it is not increasing the price every year. So maybe 3 years or 4 years once they are increasing the price. That is the reason we are getting the erratic power pricing, and the maintenance and the operational cost is also increasing. Then information lagging. Sometimes we don't know if there is a power cut, we don't get proper informations, and we don't know when it will be restored. Then adequate supply resources, supply failure. That is also another problem we are facing in the conventional grid. Losses. We are having another major problem, losses. So these all problems should be eliminated. But how we can able to eliminate the problems? Because the demand is increasing, the industries are growing, the public, they are using more components, like they are using the refrigerators, they are using the air conditioners. But when we want to develop a new power plant, we are getting the problem from the public. The public, if I want to go for a construction of a new power plant, I need a more space. So the land acquisition and available of the land, it is a major problem. In that cases, the public is not allowing, and also we need to get a clearance from different ministries. That is also a major problem when we are going for the new power plant. Then challenges in the grid operation. Grid, it is becomes more complex. Sometimes we are having a blockouts. So the blockouts, this is a major problem. Sometimes the entire network or a major part of the country, it is not getting the electricity. This is another one problem in the conventional grid. If you see, we are facing a lot of blockouts. The blockouts, it is started in 1965. The major blackout, it is happened at New York. This blackout, it is affected more than 20 million people. Then we faced another one major energy crisis problem in 1973-74 because of the Arab oil embargo. This is also created a problem in the conventional grid. Then Western energy crisis, it is also affected more than 1.5 million customers. So this picture, it shows about the different blackouts across the world happened after 2000. If you look in India, we faced a major blackout in 2012. It is affected more than 600 million people. So in the conventional grid, this is the major problem, the blackouts. We need to overcome this problem in the conventional grid. So this is the information which I taken from the Wikipedia. It shows about the different blackouts happened all over the world. So major blackout is Northeast blackout, then Arab oil embargo. These are the major blackouts happened in the world. Then the next one is different losses. Already we discussed, we are having a theft, that is a losses, and inefficiency in billing. Still, we are not going for the smart meters. we are going for the manual billing. So from the utility grid, the people they come and they do the manual billing. Sometimes there is a problem of collection also. We are not able to collect the money from the customers. So these aggregate and technical commercial losses, it is also not same in all the regions. This is vary from 4 to 40%. In India, we are having around 19%, this AT&C losses. This is also another one major problem in the conventional grid. Other than this, we are having some other problems like failure in the proper metering, appropriate tariff, and shortage of the coal, because we are having a coal, but many countries, they are importing coal from the other countries. Reduce availability of the gas, then the fossil fuels like coal and oil, they are creating the pollution, and they are creating the warming in the earth. Because of this, we are getting the acid rain. And also we have a problem in the existing grid. We are not able to transmit bulk power. Then we have another power quality issues. Customer involvement is not there in the existing grid. Then already I told you about the collection of bills. That is also a major problem. So these are the different problems we are facing in the conventional grid. These problems should be overcome by using some advanced techniques. For that purpose only, we are going for the smart grid or modernization of the grid. So what is the meaning of the modernization of the grid? So already we have a grid. So upgrading the grid in smarter way, it can be called as smart grid. So in the smart grid, what we are doing is we are going to include different rapid technological changes, like in the generation side, in the transmission side, and in the distribution side. How we can able to include the rapid technological changes? We can able to include sensors. We can able to include computer and communication based control. And by that way, we can able to increase the intelligence in the existing grid, so that the existing conventional grid, it can become as the smart grid. So when we look, the information technology is a major important one. So we are going to include the information technologies in the existing grid. So the existing grid already, we know it is generating the power at the power plant. It is supplying it to the consumers. In all these areas, we are going to use the information technologies. We are going to use the information technologies in the power plants, as well as we are going to use the information technologies in the transmission distribution sections, and also in the consumer side, so that we can able to convert the conventional grid into a smart grid. So in the smart grid, we are going to include the electrical communication infrastructures, advanced process automation and information technologies, so that we can able to improve the delivery of the electric power to the consumers, so that we are modernizing the existing grid. So when we look the overview of the electric utility industry, in the past system, we are having a system operator. The system operator is continuously monitoring the substations, is continuously monitoring the power generation units. But in the present grid systems, when we look in the present grid systems, what we are doing is we are using a different control centers in the transmission section as well as in the distribution section. Through this way, we can able to control, and we can able to monitor, we can able to rectify the faults. In the future grid systems, we are going to have different individual power producers. Like normally, if you look all over the world, maximum countries, they are only having the government utility grid. So if I need an electricity, I can able to purchase it from only the government utility. But in future, we are going to have the individual power producers. So anyone can generate electricity, they can sell it to the consumers. So in the future grid systems, it is going to include the individual power producers. Then we are going to have the electric vehicles. So already we know the diesel vehicles, the government already stopped producing the diesel vehicles. So in the future, we may have only the electric vehicles or hybrid electric vehicles. So when we look the difference between the conventional grid and the smart grid, the conventional grid, there is one-way communication. Smart grid, it is going to use a two-way communication. Centralized generation, that is the major problem. So the electricity is generated one place, it is distributed to the entire country. But when we come to the smart grid, to reduce the extending of the grid expenses, we are going to use the distributed generations. Then in conventional grid, we are not using a sensors, but in the smart grid, we are going to use the sensors throughout. So we can able to monitor based on the monitoring, we can able to take any control actions. So we are having a lot of advantages in the smart grid. So this table, it speaks about what are the different principal characteristics between the today's grid and the modern grid. When we look into the self-healing nature, the conventional grid, it is not having the self-healing nature. So the operator, he need to go and rectify the fault. But when we look the smart grid, in the smart grid, it is having the self-healing nature. The same way, when we look, motivates and includes the consumer. So in the smart grid, the consumer, he can able to interact with the grid. I can able to interact with the utility grid, but it is not possible in the conventional grid. So when we look the next another characteristics, the smart grid, it can able to accommodate all generation and storage options. So it can able to include the solar, it can able to include the wind, it can able to include the electric vehicles. These all possibilities we can able to achieve in the smart grid that is not available in the conventional grid. And also the major another one issue is about the optimization of the assets and the operation by the way of in efficient way. This, it is possible in the smart grid, it is not possible in the conventional grid. So we are having major 7 goals in the smart grid. One is consumer participation. So the consumer, he can able to interact with the grid. Then the next one goal is accommodating the generation and storage points. So individual power producers, they can come and they can able to generate the electricity. They can able to supply it to the community, or they can able to supply it to the electricity grid. And the new product services and markets, and providing the power in proper voltage and with the proper frequency. And it can able to resilient against the physical and the cyber attack, and having a self-healing nature, and we can able to optimize the assets, and we can do the operation effectively. So when we look the benefits of the smart grid, we can able to include the distributed generation, we can able to do the remote monitoring, and we can able to improve the assets and the resource utilization. When we come to the energy efficiency, we can able to reduce the line losses, we can able to improve the power quality, reactive power and real power improvement we can able to achieve. Then green agenda, because when we go for the smart grid, we include more renewable energy resources so that we can able to reduce the carbon emission. When we include more renewable energy resources, we can able to generate a lot of job opportunities also. Then customer satisfaction. So we can able to know when there is a blockout or when there is a maintenance. Everything we can able to know when the system is a smart grid. So when we look the smart grid technology, how it is covering the entire electrical grid. So we generate electricity, we transmit, we distribute. The customers, if you look, we have different types of customers: industrial customers, commercial customers, and residential customers. When we look, we can able to protect the network by using wide area monitoring, protection, and control. We mention it as WAMPAC. So the WAMPAC, it is applied in the generation, transmission, and distribution. The same way, different smart grid parameters, it is involved in the electrical grid. We can able to use the building home automation systems, because the sensors, it can able to sense the temperature, it can able to automatically switch on the heater, or it can able to automatically switch on the air conditioner. And also when I'm in the office, the lights can go for on. When I'm going out of the office, the lights can go off. So we can able to do the automation systems, building home automation systems. Then we can able to do the energy storage. Example, an individual power producer, he is generating the electricity. If there is no demand, he can able to do the storage in the battery. In the rural areas, still they are doing. In the daytime, they charge the battery. In the nighttime, if they want to use it for charging the mobiles, they use the battery. So we can do the energy storage. These all operations we can able to achieve effectively when we go for the smart grid. So when we look how the smart grid technology landscape, in generally, whether it is developed or still it is developing, how is the growth, whether it is developing very fast or it is in the moderate level. When we look, for an example, I'm taking the metering. So metering, initially we are used a mechanical type of meter, then we used electrical meter, then now we are going for the smart metering. When we look the smart metering, the maturity level, it is matured well, and the development trend, it is also fast in many countries. When we look in India, the government, they want to install the smart meters. In North India, they taken Uttar Pradesh, Delhi, they installed smart meters. In Chennai, they started in, I think in T Nagar area, but the development, if you look, the smart metering development, it is very slow in India. Generally, it is very fast if you take all over the world. So we are having a different functionalities and capabilities. We can able to know how the maturity level and the development trend. Then, when we go for the smart grid, already we know the power generated in power plant, it is transmitted and distributed. So we need to control from the generation plant to the up to the distribution. So we are using the SCADA systems. SCADA systems, it is used in different places, like it is used in the oil industries, it is used in the gas industries, it is used in the water industries, water plants, and it is used in the electrical generation and transmission systems also. So when we look the SCADA systems, it is majorly having a 3 sections. We can say it is a national level control center. Then under the national level control center, we have the regional control center. Under the regional control centers, we are having the remote terminal units. So the remote terminal units, it knows the status of the system. It sends and it transmits that information to the area control center through some communication mediums. Maybe the communication medium may be a optical fiber cable communication, or it can be a wireless communication, or it can be a wired communication. From that area control center, the information is transmitted to the system control center. So sometimes the remote terminal unit, it can able to take its own decision for the issues, but sometimes it need to get control signals from the system control center or from the area control center. So if you look how we are monitoring, controlling a substation. If you look here, we are having a different substations. Each substations, it is equipped with the remote terminal unit. So if you look the remote terminal unit, it senses the situation in the particular substation and it transmits the information to the regional SCADA center. From the regional SCADA center, that information, it is transmitted to the national SCADA center. So the RTU itself, it can able to take a decision. Sometimes it need to get control signals from the national or from the regional SCADA centers. So the SCADA centers, it improves the control monitoring operations. So if you look, we are having a master control stations, then we are having a remote substations. So here you are having a remote terminal unit. This remote terminal unit, it senses, it actuates, it senses the values in the meter. So you have a PLC also in the remote terminal unit. So whatever information it gathers, this information, it is transmitted to the SCADA master station. From there, it can able to get control signals. Based on the control signals, this remote terminal unit, it can able to take the actions. So the SCADA, one side it is having a advantages. The same time, the SCADA is having some of the problems, like it cannot able to do the phase angle measurements and the synchronization, and there is a time delay. The SCADA, it cannot able to acquire informations continuously for within a minute. But when we go for the Phasor measurement unit, it is an advanced version of the SCADA. The Phasor measurement unit, it can able to overcome the problems which SCADA is facing, like synchronization. Synchronization problem, it can able to be overcome by the Phasor measurement unit. And also, if you look the data gathering capacity per second, the Phasor measurement unit, it can able to store the informations from 30 to 120 times. So you can able to get more data by using the Phasor measurement unit. So here I'm showing an example. If you show the example, here you are having a PMU. PMU, if you see, it measures 30 times per second the information. But when we are seeing the SCADA, the old technology, it measures the voltage level. An example I can say, what is the voltage, or what is the current, or what is the frequency, what is the real power, reactive power. It can be measured by the SCADA, but if you look for every few seconds only, it measures the information. But PMU, it can able to measure within a second, it can able to measure 30 times of informations. So when we look the comparison between the SCADA and the PMU is more advanced one, and it is mostly used nowadays. Then the next one parameter, the meter structure. The existing meter, it consumes more time, and we need a labor to come and see what is the electricity we consumed. And also it is not giving an accurate information. Even we faced it in the last month. Then if you look smart meters, the smart meters, it can able to recognize and detail electrical consumption. I can able to understand how much amount of electricity I consumed yesterday, day before, last week, last month. Every information I can able to get in the smart meter, and relays information to central monitoring stations. It can able to transmit the information to the central monitoring station. So from the central monitoring stations, I can able to understand whether there is a problem in that particular house or not. It can able to replace the traditional meters, and also power outage notification and power quality monitoring. Example, if there is a outage, instead of an advertisement, the meters, it can able to show it is going to have a power outage tomorrow. Then time of day charges, like sometimes, normally we know, always we use electricity in the more electricity in the peak load time. So we can able to understand time of day charges. Based on the time of day charges, we can able to consume less electricity or more electricity. So here you can see the different meter structures. So if you see the mechanic meter, we use the manual metering and the progressive rates. The electronic meter, it is the one which we are using mostly now. So if you look, this electronic meter is also using the manual metering, and it is using the TOU and the firmware upgrading. It is possible in the electronic meter. But when we go for the smart meter is having a lot of advantages. It is having the remote monitoring, dynamic electricity price, real-time informations, and the remote controlling operations we can do, quality monitoring, and we can able to do the event monitoring also. Then this is the difference between the conventional meters and the smart meters. So we have a communication interface and a protocol. So with that, through the gateway, I can able to store all the informations, like how much electricity I consumed last month, last year, all informations we can able to store it in the database. From there, we can able to withdraw the, we can able to get back the information also. So the lot of advantages we can able to achieve through the smart meters. Then the another one advantage in the smart meter is outage management systems. What is an outage management system? So normally we are getting information from the electricity grid or electricity board. They say, okay, this week from morning 8 to evening 8, we have a maintenance, so there is no supply in that particular area. Okay, and also when there is a natural disasters, that time also we are having a major problem. We are getting the disruption in the electricity power supply. So these problems, it should be eliminated immediately. To run an industry or to run organizations, there should be a continuous power supply. So in the outage management systems, what they are doing is they are using a computer software, they are using a hardware to rectify the problems. Then they are using a telecommunication to communicate with the employees or workforce. Then operational policies and practices, so that this operational policies and practices, it can say to manage in a better way the electrical grid. So if you look, we have a geographical information systems. This outage management systems, it get informations from all, like a geographic GIS systems, then engineering analysis, customer information systems. Like if I have a problem in my home, I normally call to the customer care. I just say there is no electricity supply in my place from morning 8 or 7. So, and also sometimes we use the interactive voice responses. So nowadays we just dial the number, then we record. So this recorded information, it can able to given to the outage management system. So the outage management systems, it can able to determine where there is an outage. So the outage management systems it gathers information from different places and it uses the workforces effectively. So the workforces, they are on the systems. So I can able to say, okay, in this particular area, there is an outage. Can you go and rectify the fault? Can you monitor what is the problem? So the outage management systems, it can able to control the workforce effectively and in an efficient way. So outage management systems, it collect, organize and display the data from the field. It get information from the customers. It can get information from the field crews and the SCADA and the smart meters. Major functions, as like I said earlier, it can able to predict what is the system state, like what is the status of the transformer in a particular location, what is the status of the fuse, what is the status of the breakers, and whether there is any emergency problems or whether there is any outages. Then normally always when we do a complaint, when we do register a complaint, we normally say when it will be restored, right? So it can able to determine how much time it will take the restoration, and it can able to do the management of crews, right, in assisting the restoration, because the crew only they are going to be in the operation side, they can able to rectify the fault. So different advantages we can able to achieve through the outage management systems. We can able to use the workforce effectively, we can able to collect the informations effectively, so that we can able to supply the electricity continuously to the consumers. So when we look into the 21st century customer services, we need a more reliable electric service and situational awareness, timely, accurate communications, and personalized responses. So outage management system, it is a cornerstone of the smart grid. So it should have a proper voltage and a VAR control. It should include the distributed generation and storage points. It should have a electric vehicle and hybrid vehicle connections for charging and customer demand and energy management, and it should include the microgrid operations also. So if you look here how they are using the workforce and how IoT is used, Internet of Things, it is used all over the places. Like here we are using different sensors. As like I said, the smart grid systems, it is using more sensors, so that information it is transmitted to the all places. It is transmitted to the SCADA systems, it is transmitted to the workforce, it is transmitted to the outage management systems, so that we can able to get accurate information. So here this picture, it shows how the IoT is used in the workforce management. So IoT, it is majorly used as a physical device to connect the networks and to exchange the data also. So different types of IoT networks we can use. So that is depend on the network size. Example, if I am using between 10 to 100 meters, I am going for a home area network or personal area network. This can operate within a substation. Then when I am connecting different substations, I can say different buildings. In that time, I am going for a local area network. Then if I am connecting different distributed energy resources within 5-kilometer area, then I am going for a neighborhood area network. Then we have a metropolitan area network or field area network. Then wide area network, it covers a larger area. So we are choosing different types of IoT connections depend upon the size of the system. Then distributed energy systems also one of the important part of the smart grid. What is the advantages of the distributed energy systems? Already we know extending the grid in some places it is difficult, because maybe we need to supply to a less consumers, maybe a 15 households or maybe a 20 households. So for a smaller community, it is not efficient to extend the grid. In that case, what the government they are suggesting, they are using the distributed energy systems. When we see about the distributed energy systems, presently in most villages they are using the diesel generators, but the diesel generators, it is emitting the carbon dioxide and it is affecting the environment. So the government, it is forcing the community, rural communities, to go for the renewable energy resources. So power generation at the point of the power consumptions, it is having a lot of advantages, because when we transmit, we are having a lot of losses that we can able to eliminate when we are supplying the electricity in the same generated place. Then on-site power generation, it can able to give electricity to everyone where you are generating the electricity. If I'm having a solar power plant for a smaller village, I can generate electricity, I can able to supply it to the consumers. So it is not necessary to extending the grid. And it reduces the cost and the complexity and the inefficiencies, right? And also it reduces the losses. But it is very possible for the small scale power generations, and the reliability is more because there is no power outage because the network is not a bigger one. We are using a different types of distributed energy resources. We are using a combined heat power fuel cells, but majorly we are concentrating on the photovoltaic and wind power. Sometimes we are going for a combination of photovoltaic and wind power systems. So when we look the difference between the central and distributed generation, central generation, it is having a lot of drawbacks because there may be a possibility of losses. Okay, sometimes we cannot able to extend the grid, and also if there is any failure, the entire network it goes for the outage. That is the major problem in the central generation. But when we go for the distributed generation, here in the second picture you can see we can able to include the photovoltaic power plant, we can include the wind power plant in the grid, even we can include the CHP plant. So storage options are also available. So a lot of advantages we can get when we go for the distributed generation. Then the microgrids. So instead of expecting the electricity from the utility grid, the microgrid it can able to supply to the commercial and industrial users and the residentials, as well as it can able to use to charge the electric vehicles. So when we look the microgrids, we can able to use the generators to generate, but most we are going for the renewables, maybe a solar or wind, so that way we can able to supply to the consumers. Here I just showed some examples which we are using in the Typhoon HIL. Here I have taken a small example, one load when we are using a generator and we are supplying to a smaller load. The another one, it is using a constant power sources. So constant power sources means DC. So instead of this DC source, we can able to use a solar also. So through that, we are supplying to the smaller load. So the results for this, it is mentioned here. So how much amount of current or how much amount of voltage is consumed, it is displayed in the result page. So here I want to show about the different case studies we did for some rural villages to supply electricity to them. So it is a village, Tulutimtu. So in this village, they are having already the electricity, but we made a plan. If the conventional system, instead of the conventional systems, if we are going for a solar and wind, how we can able to reduce the cost of the systems and we can able to reduce the carbon emission. So the data is collected for all the months from January to December. This information we can able to collect from the meteorological stations. Okay, so here we are collected the information from the meteorological station in the particular country, as well as we can able to collect the information from the NASA websites. So these informations not for only 1 year, we can able to collect informations for the last 20 years. The same way we collected the information of the wind speed also from January to December at different heights. Wind speed at 10 meters, wind speed at 25 meters, wind speed at 50 meters from the NASA websites. So we can able to get information about different solar radiation levels and wind speeds, so that we can able to determine whether it is possible to go for a solar power plant or wind power plant or combination of solar and wind power plant. So when we look the village it is having a 2 schools, one primary and high school, and they have a small shops. That means this village is not very big. They are having only small 8 shops, 10 cafeterias, small cafeterias, and they are having a 2 clinics. So normally when we see clinics they always use different types of medicines. They need to use the refrigerators. They need to keep the injections, they need to keep different types of medicine. So they need the refrigerator, they need the electricity. Then one veterinary center, one historical location, then 5 government offices. So we have taken this as the primary load and we calculated how much power or how much energy they need. From that analysis, we designed the systems. So how much size of PV panel we need to supply to the consumers, how much capacity wind turbine we should use, and what is the capacity of the battery, and the sizes of the converters. So when we do an analysis, finally we came into a results. In that results, we found that the suggested solar wind systems, the cost is very high, but when we look into the carbon footprint, it is more significant, because when we are using a diesel power plant, it is eliminating the carbon dioxide. But when we go for the solar, we are reducing the carbon. It is giving more impact on the carbon footprint. But when we look into the generation of electricity cost, that is between USD 0.35 to 0.39 per kilowatt hour. The another one case study we designed for supplying the electricity to the school and the staff housing. We taken the demand kilowatt hour per day, what is the demand, and per week, in a month, and in an year. Based on that, we did a system we designed, and the students they are getting benefits based on this rural electrification through the solar power plants. The another case study, this is not implemented, but we estimated what is the energy demand for the entire village. So in the entire village, we are not going to supply electricity to all the houses. We are going to choose maybe 10 or 15 houses, and we are going to consider electricity supply to the clinic and the village administration office and a canteen and a small office. So we estimated, and this is the second phase. We are going to start this project very soon. Then another one factor, cybersecurity. Cybersecurity is also another one important term which is used in the smart grid. In the previous conventional grid, there is a lot of problems in the cyber threat attacks are there. But when we are going for the smart grid, we can able to improve the system network. We can able to eliminate the malware attacks. So this is the notable cyber security attacks happened after 2000. If you look, we have a different attacks happened at US and US, Qatar, Iran, in India also. Even recently in 2020 in Kudangalam nuclear power plant, a cyber attack. They tried for a cyber attack. Then how much amount of investment they are spending for the cost of the cyber crime study? If you see here, it is increasing slowly. 7.2 million USDs they spent in 2013, but now if you look in 2017, they spent 11.7 million US dollars. So gradually they are spending much money on studying the cyber attacks on the energy sectors. Then another one factor, the smart grid is much important when we go for the smart city. Already in India, we are doing a lot of smart city projects. The government, they approved a lot of smart city projects like Coimbatore, Chennai, Trichy, they are all Madurai, every city, they are under the smart city projects. So in the smart city projects, we need smart grid and we need a smart energy, we need a smart metering, renewable and microgrids, real-time management and control. We are bringing this all, it is a part of the smart grid. So smart grid, smart city, it need the smart grid operations. These are the references which I referred for these presentations. You can go through this book. This book, it gives more information about the smart grids, smart meters, and the smart city. And I taken some of the YouTube links. These YouTube links, it can show what is the smart grid operations, how smart city it is operating, and what are the drawbacks of the conventional grid. Everything we can able to understand. This is the paper which recently we published, how the cybersecurity, cyber attacks it is happening in the virtual power plants. That's all about my presentations. So if you have any questions, we can discuss.
Sir?
Yes, madam.
Okay. Sir, will you please be able to close the share screen?
Okay.
Okay,
No
sir.
problem.
Okay, sir.
Yeah, I did, madam.
Participants, if you have any questions to raise, you can raise questions or you can clear your doubts with our guest. Participants can hear me? Live participants. Live participants, can you hear me?
Yes, ma'am.
If you have any questions, you can clarify your doubts with our professor.
Yes, Manigandan. Yeah. Yes.
Manigandan?
Sir, now we can use a smart grid or conventional grid, sir.
Now we are using the conventional grid.
Sir,
Slowly we are
upgrade
slowly we are implementing. Slowly we are implementing the smart grid. Some of the factors, like now we can able to monitor. We can able to monitor from the load dispatch center everything, right? Some of the operations we are improving, like load dispatch centers. Previously, if you look some of the countries, they don't allow the individual power producers. But now many countries they are allowing the individual power producers. Even in India, we are having a different solar power plants, different wind power plants. They generate electricity and they supply it to the national grid, right? So when you see there is a contribution of the renewable energy resources to the grid, and also we improved like control operations. Previously, if there is any outage, we don't get any informations from the electric utility grid, right? We don't get. Suddenly the power goes off, we don't know when it will come back. But nowadays we are getting an information from the utility grid. There will be a power cut today from morning 8 to evening 6. So these informations we are able to get. So if you look, we are slowly improving the existing grid. I understand, Maniyandan.
Sir, I have one more question to ask.
Yes, madam.
So what about the challenges while facing or designing the solar cells to get more efficiency in putting solar power plants?
Okay. When you look the designing of the solar cells, normally all the countries they are not designing the solar cells. Every country they are purchasing the solar cells from China. China and German, they are the major suppliers for the solar cells. So if you look, it may be mentioned the solar panel, it is made in India or it is made in particular country, but they are not producing the solar cells. They are purchasing only, they are just assembling it.
Yeah.
Because of the cost of the production. Why they are not producing the solar cells? When you produce it, the cost is high. But if you are purchasing from outside, the cost is less. That is the reason maximum countries, they are not producing the solar cells. They are importing the solar cells and they are just assembling the panel.
Depends upon the cost of the solar panel to be purchased.
Yes, because of the cost of the solar cells. If you manufacture, the cost of the solar cells are very high. That is the reason instead of purchasing instead of producing the solar cells, we are purchasing from outside. Then just we are assembling it.
Any questions from other participants? Sure. Okay, sir.
Any other questions?
So we have some questions in chat box. We will send.
Okay, no problem, madam.
Okay.
No problem.
Kindly give your source email ID to all participants.
Okay,
If they have questions, they will send it personally.
Okay, sir.
Okay. It's time for vote of thanks.
So I take this opportunity as a great privilege to propose the vote of thanks. First of all, I thank our management and our secretary sir for granting us permission to conduct this type of technical webinar. I thank our general secretary and correspondent G. Ganesan sir. Next, my heartfelt thanks to our guest, Dr. Ravi Samikannu, Associate Professor, Botswana International University of Science and Technology, Botswana. Sir, we very much thanks for your informative speech and about the case studies and about smart grid, sir. I thank you, sir. Thank you very much, sir.
Thank you for the opportunity, madam. Thanks
okay,
for
sir.
the management and the principal and the HOD of AAA for giving me an opportunity.
In spite of critical weather conditions, you are being with us and gracing this webinar, sir. Thank you once again, sir. I thank our principal, sir, and this team of members for their excellent work. I thank you, sir, for your guidance and support. I thank my student. Thank you, sir. I thank my student participants and the other participants from various colleges in and around Madurai, from North India and all over from South India. I thank all the participants and once again, thank you one and all for your patient hearing on announcement. Your feedback form is in the description box. You can fill the feedback form and submit. You can get your e-certificates. Thank you all for your patient hearing and participation. Thank you, sirs.
Thank you. Thank you very much.
Thank you, sir. Thank you so much. Thanks for the students. Thank you.
Thank you.